Okay, guys, hopefully everybody is starting to come online. It is my absolute pleasure to welcome everybody today to our webinar on network digital twins and 5G urban mobility in the age of autonomous systems. My name is Chris Waldron. I'm the regional manager for the UK, working for ST Engineering Antecedent. And it is my real pleasure to welcome you all and thank you all for joining us today. We really appreciate you taking some time out of your important days. And we're genuinely gobsmacked to have seen the interest levels that we've had in this from people all over the world. We normally tend to see European people, but today we know we're welcoming people from as far away as Australia, the US, Singapore, and everywhere in between, as well as our normal European guests. So good morning, good afternoon, and good evening. There are those of you in all of those time zones today. Just by way of a brief introduction, I know that some of you on the call have known us for most of our 25 years of work. So there are some old friends on the call today, but there are many people who are probably getting to know us for the very first time. ST Engineering Antecedent is a rather small company, rather unknown unless you know us well. So to give you an introduction, ST Engineering has been around for 25 years. We started off with much more of a focus on first-person training. So we were really looking to help our customers with solutions for their synthetic environments, whether it was pilot training, driver training, air traffic control, ship's bridge. Over the years, we've broadened that portfolio to bring in new capabilities over time to be able to address the emergent requirements of our customers, whether it's in analysis, modeling, simulation, or emulation. We're really, as a company, focused on real-time systems or real-time simulation and training systems. And with our partners, Scalable Networks, we have been working with them for more than 15 years, I think. And we originally looked to them because increasingly our customers' applications were becoming more and more communication and sensor dependent, where actually the performance of the network or the vulnerability of the network was actually critical to their simulation and training requirements. One of the amazing things working with Scalable and their underlying development toolkits, Qualnet and Exata, is that they provide an environment where we can do analysis, simulation, emulation, and modeling, all within a common framework. So it means that we can help to address customer requirements, be they at the prototyping stage, all the way through to supporting their applications in the critical infrastructures or close to mission support. So by way of a brief introduction, that probably gives you a general overview of where we've come from and how we started work with Scalable Network. Over the years, their libraries have evolved, and today we will focus on one of the newest libraries within that portfolio, focusing on 5G. I know that the panel today is happy to take questions as they come up. So if you have a burning question, please don't keep it to yourself. Please ask when you think it would be relevant, and we've built a little bit of time into the presentations to be able to address those live. We also know that some of you will be shy, and we also know that if you all start asking questions, it will go completely mayhem. So there's also the question area. So if you want to just write your questions, please just log them in there. We will be able to see them, the panel will be able to see them, and we can start to prepare responses. We have a dedicated question and answer session at the end of the demonstration, and we can stay online for a little while if people have got things that they would like to discuss with us. So without further ado, I'm going to transfer over to Christine Van Slyke. Christine is the Global VP of Sales and Marketing for Scalable Networks. She's also the main commercial contact for ST Engineering Antecedent. So if any of you are really interested, you're probably going to end up getting to know Christine. I'll let her introduce the wider team, and Christine, over to you.
Thanks very much, Chris. So we're really excited to be here. Lots going on with respect to 5G. Let me just introduce our other team members. So we have Miguel Tinoco, who is our Manager of Application Engineering. I'll briefly go through an overview of Scalable for those who don't know us. And then Miguel will take us through what we're doing with respect to the 5G library. And Dr. Chung-Yu Liu is our subject matter expert when it comes to 5G. So he will be answering, and other wireless. So he'll be the one that's answering the questions, any specific technical questions that may come up. Okay, so Scalable, we've been in business for about 20 plus years. Our headquarters is in California. And what we do is we provide network digital twins for large scale modeling and simulation. If you look along the top, these are some of the areas where they're leveraging our software. So we do modeling and simulation for unmanned communication systems, autonomous systems. We're providing support, as Chris mentioned, around critical infrastructure, SCADA environments. We're the standard for developing and testing of battlefield communications. And of course, we also, support telecommunications organizations, IoT, manufacturing, so different areas where their networks are critical. And the value that we bring to these organizations is the predictability of the communications. So we provide the faster than real-time physics-based network models that help them accurately predict their network performance. And we model the full OSI stack. We have a wide range of protocol libraries that we bring to bear depending on the environment that you're modeling. So in a multi-domain underwater to space environment, we have all the libraries that can model that piece. We also do dual use networks. So enterprise, multimedia, control systems, and specific to today, we can model 5G or LTE environments. We also have a library, a cyber library that allows you to model electronic warfare and cyber threats across all protocol layers. We can integrate with live hardware, live applications, and third-party simulators. And we provide spectrum analysis. So when organizations are looking and managing the spectrum availability, we can do that for tactical and commercial networks. So what we do overall, as I mentioned, we provide network digital twin technology, and this enables the development, analysis, tests, cyber assessment, and training for organizations' networks, and also the applications that are running over those networks. Our core technology is network simulation, so high fidelity, real-time simulation platform, which is part of our discriminators. So we have an accurate real-time network emulation. The other piece is that we can scale to the actual environment that you're looking to model, and we do that by leveraging parallel model execution. And we have a comprehensive wireless and cyber attack and defense model libraries. You can see on the right-hand side, I talked a little bit about, but the thousands of businesses and institutions that we're supporting today. So this just helps show the different sort of the modular approach to our software. We have both QualNet, which is a pure simulation, and Exada emulation platform. So that's really our simulation core that's built on the multi-core and parallel architectures. And then depending on the scenario, you bring in the network components, the waveform or protocol libraries, the cyber behavior, the propagation, and then any of the interfaces that you need to bring in as part of that overall scenario. Now, we've been spending a lot of time on this, the network digital twin product ecosystem, and we're continually investing time to improve ease of use, and also separating it out, because sometimes there's different roles in organizations. So there might be one person that's actually developing the scenario, the front end, and then you have a bunch of researchers that are looking at doing the what if analysis. So we're actually able today to provide that in different formats depending on the requirements. So if you look at this, starting on the left-hand side, you have the scenario designer, and that's where you define the topology, the traffic, devices, everything that you're bringing in. And we have the scenario. So the two key components of that piece is the scenario importer, which is where you can import the network topologies. I'll spend a little bit more time on that in the second slide. You can also create this from scratch, but the scenario importer allows you to bring all the tools in so that you can start from, where your scenario or your network topology is today. And then we have the scalable GUI, and that's where you can modify existing configurations and view what you're pulling together. The next step would be the experiment designer. So that's really where you define the experiments that you want to run. And then, of course, you execute it on the Exada engine. And one of the new things that we've added to it is Inspector that you can see along the top. And that allows you to inspect and debug the configurations during runtime. So that's a new addition to our overall product ecosystem. And then we can bring in other simulations, as we talked about previously, hardware in the loop, humans in the loop, and then visualize, so a dynamic operational view of what's taking place. And the final piece, as we talked about, is the analyzer. So for analysts to do those what-if analysis, this is the place where you can define what you're looking for, generate the metrics, change the parameters, and then again, generate the reports at the end. And I have a quick slide on that, but you have options. So you can leverage our reports from our StatsDB. You can actually import the raw data, import into Tableau. So there's many ways that you can view that data. So this is how we pull together the automated creation, the different areas that we can import from. So if you look on the left-hand side, there's the live network. So you can bring it in from Nmap, network managers like SolarWinds, NA, and others. You can bring in the MVSE tools, Visio diagrams, network simulators, constructive simulations. This all comes into the topology converter and extractor. You can also bring in live networks like NetFlow and PCAP. You can bring in the router configuration. So if it's not already in Exada, you can bring that information in to be part of the scenario. Vulnerability assessments and live firewall rules, which is important as you're looking to model the impact of cyber attacks. So you bring this all together, and then this gives you your network digital twin. And just as we mentioned, so the reason I brought this slide up was really because we're talking about 5G today. We're talking about wireless communications, and these are everything that's taken into account in that environment. So we look at all of the physical layer side, so things like path loss, interference, fading, jamming, weather, power, and also the network effects based on the protocols, the routing, traffic, bandwidth, etc. So this just gives you a view on everything we take into consideration when we're doing that high fidelity modeling of the wireless communications. And as I mentioned, we provide reporting as part of the software through our StatsDB. And this is just one example. So this is on the network layer, and it's providing that report, but we can also take that information and send it over and import it into something like Tableau, as I mentioned, or the raw data into some type of format that you're looking to position. So I think that's it overall. I don't know if you have any questions on the overview. It was pretty quick, but I think there are a lot of people that already are aware of Scalable, and just wanted to give a quick overview on what we bring to the table before we talk to the 5G modeling. So at this point, I'm going to pass it over to Miguel, and he's going to tell us a little bit about what we're doing with our 5G library and specific modeling within the urban environment.
All right. So our model and analyst tool gives our customers the competitive edge to understand operational and business challenges across the 5G lifecycle. So meaning basically, who should be prepared for the 5G future? Early adopters investigating 5G incremental changes to existing cellular networks. IT teams developing plans to manage resources, evaluating risk profiles and effects of proposed policies. Engineers investigating protocols, infrastructures, and over-the-air cybersecurity. Organizations trying to understand the impact of ubiquitous 5G networks on their offices, campuses, and applications. So what are some of the use cases? Large customers deploy their own 5G network in conjunction with existing 4G infrastructures. We have the capability to model, simulate and emulate 5G standalone or 5G with LTE scenarios. Other use cases will be technical teams investigating cyber resilience of client deployments, policy analysts determining administrative and security issues in shared public and private environments. In this slide, basically, it shows what we actually a model in our Exada. It's basically composed of 3 parts. On the network layer, we have our 5G core network. So all those boxes that you see in red, that's what we currently support. This is going to be on the image on the top right-hand side. On the 5G, on the MAC layer, you'll see a box on the bottom right-hand side. This is what we support with RRC, radio resource controls, RDCP, packet data coverage protocols, RFC, radio link control, switch between 5G and Wi-Fi, and carrier aggregation. And for the 5 layer, this is the box that you will see on the left hand side. Some of them will be like MIMO, multi-antenna operations, and we'll go over some of this ones in a few other slides.
Yeah, I just wanted to take a second, Chris, to see, I mean, now as we get into it, there's a little bit more information. So I didn't know if, here you're sort of seeing a quick view of what we've included in 5G. We are going to go further on, in depth in that, but are there any initial questions around what we have on this slide right now, Chris?
So yeah, a question on the 5G NR model and whether it's been validated against any real experimental traffic.
Yeah, our 5G model, we have several test scenarios, and for the traffic model, I think it depends on the application. We do have more application model that models the live traffic.
Also have a question on can physical devices be included? I love this question because I know the answer. So yeah, this is part of the simulation and the emulation kernel. So the ability to be able to connect to other simulations. So those could be computer generated forces. They could be tactical level. They could be traffic. But also to be able to connect to the real equipment, whether that's a sensor, whether that's a comms device, or whether it's just one of the devices that you would normally use to interrogate the network, like Wireshark. I'm sure the panel can give a better response, but I was just so proud that I actually knew the answer to it.
That's a good answer.
So what I can't help with, so do you specifically represent QCI and ARP?
Yes, we have ARP. In our protocol stack modeling, we have ARP modeling, and for the QC, I think that stands for the quality control, something related to the tag of the packet. And yes, we do have that, and that in our protocol stack, the queue in the network queue has multiple, can prioritize and route the packets accordingly.
Is there anything else on this piece, Chris?
I think that some of the others may be covered in the demo, so I think let's carry on, and then we can ask a few more during the demo or at the end of the demo.
Great. Okay. Thanks. Back to you, Miguel.
All right. The next slide, this is basically some of the 5G model enhancements that we have recently done. Beamforming and network slicing. On the beamforming side, we support MIMO, customizable patterns. We support for open geospatial consortium and common database standards. We can accurately model the effects of the path loss and interference and any malicious nodes. For tactical battlefields, beamforming is important because it has the lower probability of detection, increased resistance to jamming. On the image on the right bottom side, we can see on the network slicing, we have the capability of sending different applications using different settings. You'll see some of those 3 applications there using enhanced mobile broadband, and some of the other ones using ultra reliable low latency communication. the ones that are using multiple ultra reliable low latency communication, they have lower end-to-end delay. For the Exada 5G assess resilience of the ubiquitous wireless network. 5G is more than a protocol, it is an information sharing philosophy. On the Exada 5G, we'll integrate with MPSC software to support testing of cyber controls and policies. Exada 5G will allow customers to investigate impact of integration historical isolated networks into a single always-on network fabric of usability, cyber resilience, and business PKI, key performance indicators. This slide basically shows that we have the capability of using different heat maps. We can also do this with terrain, and the heat maps can be displayed for coverage and performance. In this example, we can see where can we place different towers on the map, and then since we also collect very high detailed data in a database, we can see the coverage and the throughput, if it's enough to cover the specific area. And then we'll see the heat map. Right now we're showing it in a 2D, but we can also show it in a 3D environment.
So I think we're almost at the demo stage. So I don't know if there's any other 5G related questions before we get into the demo. Chris, maybe do you want to check that?
So there have been questions. I mean, one for NASA. His question came in very early, and I thought to put it at the end, but I realized he's probably really busy scribbling down answers. So the question was, are the slides available somewhere? Yes, definitely. So we can provide you the slides that we've used today. We can also provide slide decks for the wider portfolio. There are also very, very good white papers on a number of related areas, and there's also documentation that we can send through. So it's probably easiest to follow up on emails. I think that in the emails that we sent out to people who had subscribed for the webinar, there are our contact details. Wherever you are in the world, just send them through initially to ST Engineering, to the info, and we will follow up on those, and we'll also do the sort of back work to figure out who you should contact to get more local support if you have anything. There are questions that are relating to the heat maps and whether we can do that for buildings and building interiors. So I know we can bring in building data. It does ask whether we can also take in building materials. I don't necessarily know the answer to that.
Yeah, that is correct. On the demo that we're showing you, that you can see that we also take into account some buildings, S3 shapefiles that we can incorporate when we're building a model, and also we might not take into account specific material settings, but if you have the values for that PATLAS, we can import it in a PATLAS matrix.
Fantastic.
Okay. So we have one more, and then we can move into the demos.
So this is on cyber resilience. Every generation of cellular infrastructures has become more widely embedded, used, and critical. We have lots of interest in resilience in the 5G, where lots of devices are sharing information, and there will be a lot of sorts of security issues. Users of Exada can simulate different cellular communication protocols with different configurations and compare their performance. Moreover, Exada provides multiple cyber attacks that can be used to assess the cyber resilience of a protocol. And with the high fidelity implementations, users can see how the protocol reacts to the attack and even develop strategies to defend it. So this is a 5G urban scenario. What we have here is, this is urban in Boston. You can see these in 3D visualizations. What we have here is basically a drone can be flying across different points in the scenario, just below the building tops. And then on the 5G, we have different GNOBs. We have GNOB 1, GNOB 2 here in the middle, GNOB 3, and GNOB 4. As the drone is moving around, it will communicate with the closest GNOB. And we can also send pretty much any kind of traffic. This traffic can be live from emulation side, or it can be simulated traffic. Anything from UDP, TCP, or any kind of application traffic that you want to simulate. We can run this scenario in simulation or emulation. For this demo, I can run it in simulation mode. Let me see. So I'm running the scenario. We can see and visualize the burst of traffic on the network that can be building routing tables depending on routing protocol they're using. On the 5G, you can be seeing that the drone will be sending packets to the GNOB as it has a line of sight. And it will also be able to communicate with the, depending what GNOB is closer or has a range. And this is also nice because we can visualize this as it moves. We also have another tool with the scenario player that can also tell us basically as the scenario is running the throughput and any other data. As the scenario is running, we're collecting high-level statistics, and we can also collect detailed database statistics. And depending what you want to collect, we can, every single packet, it has its own unique identifier, so that way you can track it down all the way from the application layer to the physical layer. So right now, basically, we're about to finish running this scenario, and as the scenario completes, or when you stop the scenario, on the statistics side, basically I'm sending CBR, which is a UDP packets. I can see how many packets I send. I can see how many packets I have received. I can see the end-to-end delay, the throughput, jitter. And again, this is high-level statistics, but we also collect very detailed statistics. For the 5G, we can see any handover, send, and receive. And we have a lot of different 5G data that we collect. And again, this is on the application layer. Similar, we can collect on the transport layer, network layer, MAC layer, physical layer, and model specifics for the layer 2 for the 5G and layer 3. Okay, Christine, I guess I can pass this back to you.
Okay, great. Okay, so that's come up a few times, and we've been spending a lot of time updating our website. So take a look there. In all the areas, there's a solution section that provides you, some of the projects that we've worked on, the different industries that we provided support to. Also, there's videos on our 5G library with a little bit more detail, some in depth. So just take a look when you get a chance, go through there, and then as Chris said, certainly he'll send over the information on any of the contacts that I know or we have the information for. We'll connect with you afterwards for any further information you're looking for. So at this point, Chris, I'll pass it over to you to close up and then maybe open it up to further questions.
Okay, so one of the questions on there is a nice one, just asking whether we do anything to support education, whether we have sort of channels open, but I guess more importantly, are we supportive of educational projects? I know based on experience in the UK that Scalable Networks is very keen to work with universities or research establishments that are doing pure education. We also recognize that it can be applied research. that may not be commercially funded, but may be partially funded. And we have models that we can look at to try to support universities or R&D associates within a university or within a college. So yeah, that's definitely something that we support, and we can follow up and we can provide details on that. I think the only other question that sort of stands out is, I guess we've shown quite a lot today in terms of the analytical side. People were also asking whether we can simulate the effect on the network. And to be honest, that is the use case that ST Engineering and TASEET really started with. Our customers were basically building scenarios mainly for aerospace and defense, where the platforms are completely reliant on the MANET and the wider network communications. And what they need to understand is not just what happens when communications or sensors are delayed or interrupted in some way, but also how that affects the operational use of the equipment. I think that there are two really standout use cases for Qualnet and Exata. One of them is the analysis, so it's the metrics, but the other is the effect of the network effects, the effect of the performance of the network on the application. And that application can be very diverse. So in our experiences working with Scalable, as a company, we were quite aerospace and defense centric. You'll probably have noticed even from the words that I use, I've been doing aerospace and defense for too long. It is still my core market, and most of my customers are looking at Exata or Network Defense Trainer to look at how to optimize for the performance of their military networks. But over the years, Scalable's interest in the wider network communications has taken our company into very innovative spaces. That has been with the communications providers themselves, where they're looking at their own communications networks that they're looking to take online and being able to assess them, optimize them, test them before they go live. And that's taken us into projects that are critical infrastructures based. The last webinar we did was around some of the work that we can see, which is really starting to come online quickly for vehicle-to-vehicle communications. It's probably quite an obvious use for Scalable, but it certainly wasn't one of the ones that ST Engineering had in mind when we first started working with them. We now have people trying to figure out how to use the AI for driverless cars on motorways. You cannot test that live. You're not going to be allowed to just put your car on that highway at 70 miles an hour or kilometers an hour, depending on where you are on the planet. So you've got to test these things. And so we've been taken into projects that have been banking based, where they're looking at the communications that are just very secure and where they need to maintain absolute assurance of their network. And then I guess there's all of the stuff that is to do with network vulnerability, network survivability. We are all so reliant now on satellite communications. If you think of what you can do on your phone in terms of navigation or in terms of something simple like Find My Friends, my kids are all over the place. I use that all the time just to try and figure out where the hell they are. And yet we've become absolutely dependent on these things. And when they don't work, we're almost lost. So I think that the application use cases are expanding very quickly. So, if you have novel ideas of how you might want to use this, if we haven't mentioned your area today, please just tell us what you're trying to do. If it's communication network based, if you're looking at performance, or you're looking at survivability or vulnerabilities, we may be able to help. And obviously that's what we would love to do. So I think unless there's anybody with any new questions, we can probably wrap up for today. We wanted to give you a snapshot on what we've been working on, but there's lots of follow-up we can do. Locally, we can set up virtual demonstrations of the capability that are more attuned with your use cases. So we just need a little bit of information to be able to tailor things around what might be more relevant for you today. I can see that Christine has a question.
The only thing I wanted to add is, as we look at the 5G library, I mean, basically what we've modeled already is input from what our customers are telling us they want to model. So if there's something in there that doesn't, reflect your use case and you'd like to have something added, then don't hesitate to let us know. We are very open to input on what's required as part of that model. So I just wanted to add that.
Yeah, I think we've seen that over the years. So when we've had cases where customers have been particularly interested in an area, and within a year or so, we've been able to go back with a module that maybe helps them. I think the one that really sticks out for me was the marine communications. So I don't think when we started, we didn't expect submarine guys to be saying, hey, we have comms problems too. So we do learn as we go along, and Scalable Networks has a very diverse and very, very capable team that is constantly looking to develop the libraries so that we can meet our customers' requirements. We do need your input. Without your input, we don't know what to do. So I think we can probably draw things to a close. Please do continue to communicate with us. We will almost certainly do a follow-up just to thank you in person for attending today. And seriously, guys, we really appreciate you taking time out of your day. So thank you very, very much. And it's nearly Friday. It's nearly the weekend. So I'm going to close out today. Big thank you to everybody for attending.
Thanks very much. All the best.
All right, thank you.
Thank you.
Bye.